Hello everyone, welcome to MSTW 2022's Data Workshop, Breaking Down Data. I'm Jia Xiang, your moderator for today. Along with Imran as assistant moderator, Malaysian Students Technology Week is Malaysia's largest student-led technology conference, and we are back again this year as a 9-day fully virtual event filled with talks, workshops, and a hackathon to look forward to. As for the theme of MSTW 2022 this year, we have chosen sustainability to highlight the rising demands from the increase of global populations coming into direct conflict with the health of our planet. We aim to share with participants on three pillars of sustainability, namely social, environmental, and economic. Balancing all three pillars ensures the protection of the environment while improving the quality of life. To complement the theme, we will have four sub-themes in our MSTW, namely data, AI, energy, and biotechnology. Multiple workshops and conferences are held around the sub-themes. And for today, it will be the first day of our weekday events, themed data, starting with this data workshop, and we'll have another data panel discussion in this afternoon. Back to the event, our workshop today is dedicated for you, our audience, to have a look at different stages of the data science life cycle and expose you to some of the data science tools and libraries. Our speakers today is Dr. Lau Che Han, currently the CEO of LEAD, an institution that provides programs on data science, full stack web development, and digital marketing. Dr. Lau is also the founder of the coronatracker.com and previously the co-founder and CTO for joinhappen.com and previously the co-founder of Hero Boyfriend. With his 15 years of experience working in software development, database technologies, data mining, and analytics, we believe that Dr. Lau will bring us a meaningful workshop today. Without further ado, let's welcome Dr. Lau to have the data workshop, Breaking Down Data. Welcome, Dr. Lau.
All right, morning everyone. You guys can hear me loud and clear, yeah? So I won't be there's some problem with my camera. I'm not in my office today, so I'm not with my typical setup. So but I will be able to share screen and also to walk you through all the things that we need to cover. So like what Jiaxiang has said, today I'm going to give you a workshop on how to use data science to solve real world problems. So let me share my screen. Okay. So data science is a scientific subject that is interesting because when it comes to data science, a lot of people were wondering like, what's data science? Everybody is talking about data, big data, data analytics, data science for many years. But most of the time, especially while you're in uni, right, you use a lot of data. You are supposed to use a lot of data to back your research, to back your findings, to back your homework. There's still no one, I would say, no one clear idea about what is data science and how do you actually apply it at work. So today is to give you a sneak peek and help you to shape your career path in case some of you want to pursue a data science career after you have graduated, and this will be a good eye opener and exposure for you. The potential career when you work as a data science professional, right, is not just data scientist. When it comes to data science career, the first thing that came to people's mind is, oh, I learned data science and I'm going to become a data scientist. That's not really the case. You have a couple of options here. Number one is data analyst. Data analyst is similar to data scientist, but data analyst focus more on historical data. That means you get a set of data, you analyze the data, and then you tell your audience. It could be your boss, it could be your stakeholders. You tell them what this data told us. For example, if you are working in, let's say, United Nations, we have a lot of historical data. We have economics data, we have population data, we have political data, and all these sort of data, you can use them and combine them to cross-reference, cross-check with each other to see what the data tells you. Right? That's one uh, key things that data analysts do. And another thing that they do is they use some simple models to analyze the data and make some prediction. So they don't do hardcore predictions like what data scientists do. And they usually the skills that you need are SQL, and also visualization tools like
Dr.
Tableau,
Lau,
Power. Yeah,
sorry to interrupt. Are you sharing the slide?
yeah, I'm sharing the screen. You can't see it.
Because we can't see. Yeah.
Okay, okay. I'll share again.
Yeah, it's here,
Able to see
doctor.
now?
Okay. Yeah.
Okay. All right. So the first one is that's data analyst, right? That I've just mentioned. Then the second one is data scientist. Data scientist is a role that everybody knows, right? Everybody has heard of. If every single company, especially those the so-called FANG company, Facebook, Apple, Netflix, Google, any company that you have heard of, the big tech companies, Uber, Tesla, whatever, they all hire data scientists, and they don't just hire one data scientist. They have a lot of data scientists. So these data scientists, they do similar things as data analysts. They take historical data, they build models. But once they have done that, right, the next thing that they do, not just analyze the data and then tell you what they can find from the data, but they build models as well. So we build models to help us to explain our data and help us to predict what is going to happen in the future. There are two types of predictions. One is what we call supervised learning. Okay, supervised learning, we use historical data to make classification and also forecasting. So if you are classifying something, that means you are trying to predict some, what will happen or what will not happen. And if you are forecasting something, that means you are trying to forecast a future value. So classification, for example, is like we have a lot of movies in Netflix. We want to classify them into whether they are comedy, whether they are thriller, whether they are scientific fictions, and so on and so forth. So that is what uh, supervised classification does. And another type of classification is, another type of supervised learning is regressions. So regression is for us to forecast a value. So for example, you want to forecast the demand of grabs grab cars in the next hours, or after you have known the number of cars and number of passengers in a particular area. Let's say you're in KL, right? You're in SS2, you're in Subang. Then you want to forecast the best price, or you want to predict the best price that people are willing to pay for, and the drivers are willing to come and pick up the passengers. So this is what we do for as a data scientist. Okay. Then you have other jobs as well, like machine learning engineers, data engineers. Data engineers are, for those of you, if you are from networking background or you like things like networking, you like things like, let's say, uh, connecting data together and putting data onto a platform, then data engineer is a job that's for you, because this job requires less speaking to customers, less business oriented uh, decisions making, but it's more on the hardware side, it's more on the cloud computing side, it's more about building a scalable platform. And of course, machine learning engineers is you are going to build models that specifically for machine learning. And lastly is AI developer. So at your stage, right, you might confuse between machine learning and artificial intelligence. Machine learning is the models. Okay, machine learning is the core, it is the engine. AI is the application. So to be exact, on a strict definition, right, there's no such thing as AI study. So AI is not a technique, it's not something mathematics, it's not something physics or engineering. All those hardcore stuff are done in the machine learning. AI is more on the philosophy side, on applications, and also on the ethical side, I would say, right? The humanity side. So if you develop AI applications, how many people's job will be replaced, that sort of things. Yeah, but it's all part of the industry revolution. So that's the broad career areas, or I would say companies in Malaysia they are hiring for for those data science positions. And then next, let's quickly look at the data science workflow so that you can understand what the workshop is about. When we work on data science project, right, or when we work on any projects, the scariest part is you don't have something to follow. You don't have a workflow. You don't know what to do. You did not follow the sequence, right? So the best way to do is we follow a framework. In this case, we have this thing called the Awesome framework. Awesome is not because the framework is awesome. It's a pun, right? It's a short form of the 5 steps in data science combined together: obtaining data, cleaning data, exploring data, modeling data, and interpret the results. So these 5 keywords combined, and the first word of each steps combined is called awesome. So the first O is to obtain data, is to gather data from relevant sources. Because if you don't have data, you can't do anything. Then the second step is to clean the data. All right. So we call it scrubbing. And to scrub the data is because we want to clean the data to make sure that the data is understandable, and the machines can understand those data that we provided. So you should know, right? Data science, oh sorry, computers only understands numbers. To be exact, they don't understand numbers as well. They only understand signals. That means 0 and 1. We use 0 and 1 is a binary systems, and then we can convert into decimal systems and other sort of numerical system. So in a way, computers understand numbers, but it does not understand images, text, or videos, audios. But in today's world, we have a lot of data, and that's what we call big data. We have your Instagram reels, your YouTube shorts, your TikTok videos, and all your interaction with those apps, right? And those are unstructured data. And that's why every time when we process the data, we have to clean it and make sure that the computers understand those data. And the third one is explore data. Now, you might wonder, right? A lot of people say modeling is the most interesting part, is the most important part. Yes, but modeling is the easiest part. Yeah, the hard part is to explore the data to find patterns and trends. Is basically like what I've told you earlier. What this data told us, right? This data representing something, and what are some insights that we can find from this data. Then you go on to modeling. Modeling is to train the models to predict and forecast the things that I've told you earlier. You want to predict what is going to happen. You want to predict whether there's an earthquake or not. You want to predict whether the price of a Grab ticket, Grab ride fare, etc. And lastly is to explain the model and results. So because of deep learning and AI, today we have a lot of advanced models out there already. So all these models are very chunky, I would say, right? It can do a lot of things, but a lot of those models, they are complex, yeah, and it's not really under explainable to normal people. So when you go to work, you have to make sure that you are able to understand the models, explain the models and the results, just like what you are doing with your uni lecturers like that, yeah. So if you write your reports in a too technical way, they don't understand, then they won't give you high marks. So it's the same reason. Okay, so let's move on to our hands-on lab today. So what I want you to do now is to go to, uh, I'll put down the URL. Okay, colab.research.google.com. Oh, I can't put in the comments. Yeah. Okay. And then that is the tool that we are going to use. That's the Google Colab. The next thing is I want you to go to this URL to download the Excel spreadsheets. I'll give you 2 minutes to look at the Excel spreadsheets. Okay, so take a look at the Excel spreadsheet for 2 minutes and then tell me what you can find from that Excel spreadsheet. Okay, any questions you can type in the comment section. I'm able to see, just I'm not able to comment. And I'll teach you how to, I'll walk you through how to analyze data using Google Colab. Google Colab is a tool that's what we call a notebook. Yeah, when we use like Python or any sort of data analytics tools. And Google Colab is a public version, it's a free version that you can use. So when you go to work, you don't have to worry about anything. You just, as long as you have internet connection, you will be able to access this website. Okay, so feel free to type what you have find out in this Excel spreadsheet. You can use any tools. You can use Excel. You can use all sort of tools. You can use pivot table. Okay, another 30 seconds. And then once you're ready, you can go back to Google Colab, click on New Notebook. Right, so if you have any, because this is not a Zoom meeting, so I won't be able to hear you. So if there's anything, just I think the host can turn on your mic and let me know. So first thing first, give your notebook a name. Say MSTW Data Science Workshop. Okay. So the first thing that you do every time when you open a new notebook, right? You do two things. Import the library first. Okay. For different use case, okay, the programming language that we use today is called Python. Right, we're using Python 3. It's a very versatile, very powerful programming language, and every places that you go, as long as you master, you pick up Python, you will not have problem or trouble finding job anywhere. The two most popular programming language in the world is number one, Python. Number two is JavaScript. Depends on the chart that you look at. Some of them, if they are more web focused, they will be more JavaScript driven, sorry. And if they are more back-end driven, then they will use more Python. But the popularity is there. So we need to import libraries. Sometimes if you are working on some geographical projects or you are working on some science project, right? Then you need to import different libraries. But for data science, we usually import pandas and also Seaborn. Pandas is a package for us to analyze data, especially structured data, so we can use them in a form that looks like Excel. And Seaborn is for us to produce beautiful visualization. Okay, so we are going to use these two. Now, how to run this cell? You can click this play button here or press Shift Enter. Now, in case if you have any issues or you want to get the code later on, right? And also my slides, you can send me an email. cloud@david.io. Okay, I'll share a copy of the slides and this worksheet with you. Okay, so the next thing that you need to do,
Dr. Lau,
yes,
there's a question from the audience. Good
yeah,
morning, Dr. Lau. What does the last evaluation stand in the data set?
last evaluation, Maxine, right? Yeah, Maxine, uh, can you rephrase your question a little bit? Evaluation means we want to assess uh, the performance of our model. But last evaluation, maybe you can give me the article or a bit more context, then I'll be able to answer you correctly. Yeah. Then the next thing that we do is we're going to read the dataset or Excel file into our workspace. So we're going to say df equals to pd.read Excel. And the good thing about notebook is or Python notebook, right? Is able to read directly from GitHub, okay, or from anywhere that hosts your data set. So you just go to the page that I given you earlier, right click on download and select copy link address and then put it here and then run the cell. Okay, once you see a tick, that means the cell has been executed successfully. I can put the URL here. Yeah, sorry, I can't comment. That's and then you can type df to take a look at the data set. And when you go to work, make sure that you understand the definition of the table. So right now, because it's an exercise, right, I will tell you. The first column is their name, and then the second column is their satisfaction level. Satisfaction level means this employee, this staff, are they satisfied working in this company? Are they happy or not? How happy are they? All right, is a value from 0 to 1, between 0 to 1, and last evaluation is the score that the boss give the employee. That means are they happy with their performance, basically. So the first column is the company that you give to the company. The second column is the company gave you. And this is what we call a continuous number. That means you have decimal point. And the third column is number of projects. So how many projects that this employee was involved in the past 365 days. So usually in HR life cycle or HR reporting cycle is 365 days. That means they do a HR evaluation once a year. Sometimes they do once a quarter or once every 6 months. That depends on the company. But usually especially for big companies, they do it like every year. And then we have average monthly hours. This is how many hours that this person has worked in the company, and then EXP in the companies, how many, what is their experience, how many years they have worked in the company. So these are what we call, for these three columns, right? This is what we call the discrete numbers. Discrete numbers are discrete data, are numbers that we can count, but we cannot measure. For example, you can count how many books are there on your bookshelf, right? How many cars your fathers have, for example. That can be counted, but you cannot measure. You cannot use a tester to test how many cars your father has. Yeah, so that's something that can be counted but cannot be measured. Whereas like last evaluations, satisfaction level, or temperature, your weight, these are something that can be measured but it cannot be counted. Like you cannot look at a person and count how heavy is he. Yeah, so that is the difference between discrete and continuous. And then we have another three columns here: work accident, left, and promotion last 5 years. This represented the values that uh, is 0 and 1, not 0 to 1, but 0 and 1. That means it's Boolean, it's true or false value. Okay, so these are the values that is true or false only, and 0 means false or no, 1 means yes. So if you look at work accident, 0 means this person has not met any work accident, which is most of them, they did not meet any work accident. And then promotion last 5 years is, did this person get promoted in the last 5 years? Okay, most of them they did not get promotion as well. That's why a lot of people left the company. Okay, so we look at left. Left means whether this person has resigned or not. And then we have role and salary also. These are just two text column. Role means the department that they came from. Salary means the salary that they are drawing. Okay, so this is the overview of the data. And if you want to know more about the data, like how many rows are there, what are the data type, you can use df.info. So df stands for data frame. So when you see there's 15,000 entries here and 15,000 entries here, that means all the rows and all the our data set, they are tally, so there's no missing data there. Yeah, there's no missing data there. Okay, any questions? Feel free to leave them in the comment. Oh yeah, you mean the last evaluation, correct? Yeah. So last evaluation means uh, the evaluation score. That's a good question. Okay, you need to ask when you go to work, right? You as a data science person, you have to keep asking questions. it, I always say, right, in today's world, it's not hard to find answers. Answers are everywhere. You just Google it. Yeah, but it's hard to ask questions. So if there's any tips that I can share with you, right? Any takeaway, make sure you learn how to ask the right questions. Okay, so now that you have a lot of columns, right, a lot of data, the next thing that you need to do is to get a better understanding of the data. So in order to do that, we can use a technique called describe. This is a very powerful technique, which is what we call descriptive analytics. Okay, this will do the magic. Just type df.describe, and it will give you a descriptive table, and it basically tells you every statistical thing about your data set. Okay, take a look. I'll give you 2 minutes to do that. We got some time. Feel free to ask questions. Okay, be
Dr. Lau, there's another
Yeah.
question
Yep.
from Moazim. Who'd like to ask how different is R from Python?
Okay, Wazim, that's a good question. So there's no difference between I shouldn't say no difference. I mean there's no difference between the output of the work from R and Python. Okay, the language themselves is this. Python is designed by a computer science guy, and R is designed by a mathematician. So you can, if you're from a mathematics background or you're from a strong statistic background, right? R language will be more familiar to you. But I'm from a most of the people who are working in data science, they don't directly come from a maths background, and that's why a lot of us we chose Python as our de facto language. But once you have mastered one of them, right, it's not hard to switch because the context, the lingo, the syntax, they are very similar. Especially the thought process, almost the same. And if you go to R, right, you have similar command, you have similar packages like dplayer, tidy, those sort of package. Whereas here we use pandas, we use seaborn, and they have ggplot. We have ggplot as well. We have matplotlib, just to name a few. Okay, so that's the primary difference. So if you go to work, right, I would say most of the companies in Malaysia, they will hire somebody who knows Python, and then some of the research facilities they have a strong requirements for R because of the package that they use. Other than that, there's no there's no strict difference between these two. Another reason is Python. We can directly build web applications and take our models output and use that on a web API. But for R, you can't. Yeah, R you we have Shiny, we have R Shiny package. It's just for you to build a simple website. But if you want to take this to a scalable program, let's say last time we had these consulting projects with Intel, right? So they have a lot of data models, all those semicon manufacturing stuff that runs on Python. And then we can directly take those results and put it into a web application using Django or using Flask. But if you use R, then you have to find another ways, some other ways to do that. Yeah, it's not that straightforward. So the main difference is there. Yeah. And that definitely no such thing as one is better than another. It's like you are not going to say English is better than Malay, or Bahasa Malaysia is better than Bahasa Indonesia. That sort of comparisons. Yeah. So they are very similar. It is widely used in data science community. But of course Python is more popular lah. Yeah. Okay, so let's look at this descriptive analytics result. So it will tell you everything that you need to know: the count, the number of rows there, and the mean is the average, STD, standard deviation. If you are from a statistic background, then you should be quite familiar with standard deviation. What it means is for you to check how far are your data points from the center. Mean is minimum, max is maximum, and then you have 25% mark, 50%, 75%. These are quartile. So for example, right, I want to answer the question, say, how many percent of our employees have left the company? Okay, so that's a very common question that we usually ask. What is the turnover rate in our company? So you can go to the left section and look at the mean. Okay, and this is the result. 23.238133. So 0.23. You take these times 100, it means 23.81% of the employees have left our company. Yeah. Okay. And then if you want to know like how many percent of the people, let's say, okay, we want to know whether this employee, whether they work hard or not, right? So we can look at the average monthly hours. On average, people work about 200 hours, 201 hours, and we look at the 50% mark. It's 200 hours. So half of the 50% of the employees in the company, they work, their target meets the average monthly hours. That means they are 50% of the people, they're working at least as hard, or if not harder, because you see the guy that work the hardest, they work 300 hours per month. Yeah, so it's still quite a hardworking company. And we can look at the work accident. Okay, how many percent of the people have met a work accident? You look at this, 0.14, so about 14% of the people. You want to know whether this company is a young or old company, we can look at the experience in the company. On average, people work for 3.5 years, and 75% of the employees here actually has work experience of 4 years or lesser. Okay, 4 years or less, fewer, 4 years or fewer. So you know that this is not a really old company now. Most of the people there only work for 3 to 4 years, as in they are only in the company for 3 to 4 years. Okay, so this is what we call descriptive analytics. Yeah, you're welcome, Mozin. Okay, descriptive analytics. Okay, so this is one thing that I would like to share with you. Now, the next technique that I would like to share is how to draw chart. So we can use what we call a cow plot to count something. This is a very useful technique because you always need to create visualizations when you work on projects. So you can say, let's do X equals to salary. Okay, data equals to DF. So this DF is the data frame that you have created. So now you can count how many employees are in the range of low salary, medium salary, and also high salary. Okay, I'll give you a minute. Give it a try. Okay, let me know if you have any questions. Yeah. And you can change it to other columns, of course. Like let's say uh, number of projects. So remember, anything that you can count, you can use a count plot. You can also count the people in the department. Okay, so the word overlaps a little bit, but that one we can fix later. So let's say now we want to know which number of projects, right? And also the relationships between, does it affect people resigning or not? So meaning that some people, they work a lot of projects, they're more likely to resign, right? We can add another layer called hue, and then we set that to left. You can always send me an email after this to get the full copy of this and also the slides. Okay, my email address is here. I can put my email here. So you just need to run this. So this gives you a better perspective on the data itself, right? You can see that at first you think that only people who work more projects, that means like 5, 6 projects, they are more likely to leave, right? But actually it's not. 5 projects is still okay. Yeah, 3, 4, 5 projects is a sweet spot. People who work 6 projects, they cannot tahan, right? They need to resign. And then 7 projects, they definitely will resign, overwork. But okay, there's always a but. Surprisingly, when they look at low, like this, right, low number of projects, they didn't get enough opportunities to perform as well. So they will quit. Yeah, see? So the 2 projects also they will quit. So why are we doing this? This is what we call the exploratory data analytics. Okay, exploratory data analysis or analytics, EDA in short. So why do we need to do this? Because we are preparing for our machine learning model. Yeah, we are going to prepare it for our modeling stage. So the next stage is we are trying looking for features that are good for modeling. So we are looking for features that we know that can help us to build a good model. So what we can do is we can select some features, let's say satisfaction level. We know that satisfaction level is going to affect somebody whether they're going to resign or not. And the second factors that we found is probably number of projects, as we can see here, right? So these are some of the distinctive features that we can use. So here in this step, we are going to prepare our training data sets for building models. And we're now entering the machine learning stage already. Okay. So we can say the X that we want to use is df bracket features. Y is our left. So in machine learning or in mathematics, right, X is our input. And since we have multiple inputs, so we use capital X. And then this is our target. Okay, that's what we want to predict. Any questions? Okay, and then what we need to do, right, is we need to split our data into training and testing set. So why do we need to do that? Because we want to check and make sure our model is performing well. So we want to reduce all the biases, we want to reduce all the variance, all the possible noises. Yeah. So we need to split this, and the rule of thumb is 70% training and then 30% testing. This is not a golden rule. That means you can adjust the portion and see which one works well and give you the best result. So the code is here: X train, X test, Y train, Y test equals to train test split X, Y test size 0.3. Oh, yeah, not import the package. Yeah. So for machine learning, see, this is what I meant, right? For machine learning, you need to import another package. Piece of code. Yeah. Okay, there's a question from Monzim, right? Are there any conditions that require us to change the ratio of training and testing set? Yes. So sometimes I use 80-20, sometimes I use 70-30, and depends. If your data is big enough, right, then your training set need not to be too big. That means when you have 1 million data points, which is still considered small in most cases, right? Let's say you have 1 million data points, and whether you use 10,000 or 20,000, it doesn't really make too much of a difference if your data quality is good. But if your data is very dirty, right, that means if you take this 10,000 from the top 10 and you take this 10,000 from the middle chunk, the performance varies. Then that's a signal, okay, that's a sign that your data might not be clean. So, or the features that you choose might not be a good feature. Yeah, so you might have to reconsider that. Okay, I hope that answer your questions, Mazim. And this is uh arbitrary, okay, in academic sense, arbitrary or heuristic. That means based on your gut feeling and experience in a way. I'm laughing because that's the best way to put it. And okay, let me be serious and tell you something that's more professional, right? I'm data scientist. In a more professional way, we usually set a ratio. Let's say we set the 30%, right? And we still run this experiment 10 times because these values or this split is done randomly. So if you're done randomly 10 times and the performance remain consistent, then that means your model is okay. But if you do it 10 times and your performance fluctuate, that means the train test split or the data set that you have chosen got some problem. Okay. All right, so the next thing is k nearest. We are going to build our model. Yay! Build our model. I'm going to say from sklearn not neighbors import k neighbors classifier. Okay. For those of you I'm going to enter the Q&A in a short while. But for those of you who are interested to learn more about data science, live about data scientists, how do you choose your research, should you pursue a PhD, you can always reach out to me. Yeah. K nearest neighbor. I'll give you a quick walkthrough on this K nearest neighbor model that we use. There are many different models that we use for classification. The common one that you would have heard of or you have seen is like logistic regressions, decision trees, for example. And K nearest neighbor is one that's more intuitive. So if you look at the chart that the picture that I select here, right? So imagine you have two types of items that you need to classify. Let's call it cats and dogs. The blue box represents cats, and then the red box, the red triangles represents dogs. So you jot down their features and you build the model. Okay, so this blue color one, 2, 3, 4, 5, 6. These are 6 cats images, and then 1, 2, 3, 4, 5. These are 5 dogs images. Okay, and then once you put down these images, you train the model. You extract their features like the skin textures, the colors, etc. Okay, what makes a good features when you want to differentiate cats and dogs? You probably look at their textures and their features, right? Their eyes, their height, their length, because dogs are technically a lot bigger than cats. Sometimes, well, a good example of bad features is you look at the number of legs. Both of them have 4 legs. So if you use number of legs as your features, that's a bad feature because both of them have 4 legs. This is just to give you an idea about how to differentiate between a good and bad features. Okay, now you have a new picture that comes in here. Okay, this green color dot here is a new picture. So you want to use the machine to help you to classify whether this is a cat or dog picture. How do you do that? So using k nearest neighbor, what we're going to do is we're going to look at the images that is closest to this image. Okay, so we look at the green color button here. Obviously, it's closest to the two cats. Dogs image here, right? Red colors means dog. So this green color dot, of course, is a dog picture. Okay, so we're going to say this is a dog picture, and that's how k nearest neighbors work. So go back to our code, right? We're going to set k nearest neighbor classifier and n neighbors equals to 5. So we're going to look at 5 data points that are closest to the unknown and use that to classify. Okay, so I must have typed something wrongly. K neighbors. K. A sec. It looks exactly the same, but it's just
Doctor,
yeah.
this from audience say that the K need to be capital letters.
Oh yeah, that's right. Yeah, they changed the right. All these sort of things. Mm. Okay, all good. Then you just type k nearest neighbor dot feed x train and then y train. So this feed means feed our data points into the model. Okay, and then you would have built your model. Then the next step is to check the performance accuracy of our model. So we are going to import sklearn.metrics, import accuracy score. How come I was copying from the documentation? Oh, it's a capital K. Oh, okay. See, copy paste also can be wrong. All right, predictions equals to k nearest neighbors dot predict x test, and then accuracy score y accuracy score equals y test prediction. Okay, so this is the accuracy score of my model. Now, as I told you, right, it's a random process. But if your score is somewhere between 91, 92%, or like mine, 90%, it is okay. It's considered very good. Yeah. So I'm going to paste the code here.
This is another question in the comment, Doctor. From Vignesh. Do we need to understand what each and every model do, or try and error with different models to get the desired results?
That's a good question, Vignesh. You need to understand every model do. You don't have to understand the mathematical parts. Okay, even for me, I understand how it works. I try my best to understand the maths behind, but not all the time. But you need to understand what is good for and what is bad for. For example, right, k nearest neighbor is good, is kind of like resilience, a little bit more resilience to outliers. And then for decision tree also is good for both uh, classification and also forecasting. Like k nearest neighbors, we don't usually use that for forecasting. We don't usually do that. And like linear regression, for example, it can only use for forecasting. You cannot use that for classification, and it's very sensitive to outliers. That means, let's say you are trying to predict the sales for the next quarter, and then for the past 3 months, your average sales every month is like 50,000, 50,000, and then got 1 month you run a promotion, you get 120,000, for example. But that is an outlier, right? That does not represent the normal sales capabilities of your company. Yeah, so that is what I meant by outliers. So they're usually things like, is the model sensitive to outliers, and whether it's the model is what do you call it, parametrics. That means, is it very relying on the quality of the parameters, and do you need to normalize your data? Like in this workshop, of course, I skip a lot of steps, right? Checking the data qualities, checking whether the data they are dependent or not, etc. But that's a very high quality good question. So. Once you go into work, right? Especially if you are not from statistics or maths background. I don't come from that. I come from a com science background. In fact, I come from software engineering. I build apps and web applications, mobile applications. So a lot of times when I want to do something, I'm just too lazy to figure out what is the theory behind. I will just do try and error, because when it comes to the stage of big data, is the amount, is the volume that matters. Yeah. So it's not, statistical methods are more, most of them they are based on uh, sampling method, but I'm more of a frequentist. That means I don't just look at the theory, but I look at the frequency of something that happens. And when the data is huge enough, right, everything is significant. Yeah. So okay, so the last thing that I would like to share with you is, now you have built a model, right? So let's use our model to predict. Okay, so you want to call the model and say k nearest neighbors dot predict, and remember what you have chosen for your features. You have used satisfaction level. Thank you, Mary. You have used satisfaction level and number of projects, right? So your satisfaction level, you can use a let's say 0.6, okay, just an imaginary one, and then number of projects. So four projects. So meaning that if a person satisfaction level is 0.6 and handles 4 projects, he going to resign? Okay, so the result is 0. 0 means he's not going to resign. All right. So if a person satisfaction level is 0.3, he's still not going to resign. But if you give this person 6 projects, I'm still not going to resign. Okay, 7 projects. Actually, 7 projects, they will definitely resign. Okay, 0.1, 2 projects. Yeah, so low satisfaction level, low projects, they are going to resign as well. Okay, you can play around with it. Okay, Vignesh has a follow-up comment. If we understand the general difference between classification and regression and which model works best, it'll be good, right? Okay, the general difference between classification and regression, you have to understand by the time we end this call, we end this workshop. That means classification is to predict an outcome. Regression is to predict a value. Regression is to predict a value. So this is the first thing that you have to understand. And then at which model works best for each will be good. Yes, correct. Yeah, because there are models that works well for numbers. There are models that works well for images. There are models that works well for what do you call it? Audios and text. Yeah. So you really have to study the differences and how to apply. That's right. Okay. I'll be answering questions for technical questions for another 5 minutes maybe, and then we can enter the Q&A session.
So here's a question, Doctor.
Yep.
It's from Moazim. He's asking, is there a way we can plot the predictions we made just now?
Okay, so the predictions that you have made, right, is actually just another column. So you, I don't have time to show you everything here, but I can show you the thought process. You basically create another column called predicted, and then get all your predicted results, right? Let's say you can add your predictions here. Because your prediction is just another bunch of left and whatnot. So you plot these back to your original plot. Yeah, and using scatter plot. You give it a try, and if you have any technical issues, can drop me an email. Any questions? I'll be here for another 15 minutes until 1:30.
All right. For our audience, do share your questions regarding the workshops or even regarding the data science in the comment sections so that Dr. Lau will help in answering the questions. So while waiting for that, maybe I'll have some questions for Dr. Lau.
Yep.
So, because there are some of our audience are from engineering background,
Yeah.
so in your opinion, do you think that if like we are students from engineering background that we found that we have interest in this data science, do you think
Yep.
is it possible for us to have the track change into the data science field?
Okay, so you don't really have to think of it this way, like uh, I'm switching into data science. Data is going to be here, and eventually every company is going to become a data company, and you can see this everywhere, right? So if you're engineers, and you should see data science as another skill that will up your value. Let's say you are a mechanical engineer, so you are not going to switch to data science and become a data scientist just for that reason. But you should continue to work in mechanical field and combine your mechanical engineering knowledge with data science, and that will make you a more valuable mechanical engineer compared to normal mechanical engineers who does not know any data science at all, or even more valuable than a data scientist just like myself, because I don't have any domain knowledge in mechanical engineering.
I see. So, if
Yeah.
for the new learner, is there any platforms that you would suggest for us to have the fundamentals knowledge or basic
Yes.
training?
Go to this website called Kaggle.com. Yeah, I think some of you know that, right? So Kaggle.com has all the information that you need, including data sets, tutorial, and of course you should go to my YouTube channel here. We have a lot of free stuff, free resources here as well.
So, for the application of data science, is
Mm.
it Python will be the most common language to be used?
So if you are a complete beginners and you are choosing between, so you're tossing the idea between Python and R, right? Then
Mm-hmm.
just go for Python first. Unless you are from, let's say, your engineering background, some of the subjects that you have taken use R, or you're from like those biomedical, I know that they use a lot of R as well. And then you can go ahead and use R. There's no problem. It will not hinder you at all. But if you are just a beginners and trying to choose between Python and R, then Python will be a much better choice, beginner friendly, easier to pick up, and a lot of tutorials out there. Yeah. And another exception, probably like you are from, let's say, uh, those qualitative. I think qualitative research. Yeah, you use SPSS, or you have your own industry software, right? Yeah, then you can
Mm-hmm.
try out and see which one you have a better feelings. Yeah, you have a better grasp of it. But technically, there's no difference between those two. Is Both are very widely used in the industry.
I see. Then, for now, currently in Malaysia, in which industry that data scientist is mostly used? Will it be those internet or high tech company, or actually even those basic like all constructions, or yeah, also in requires have the demands of data scientists?
The one with the highest demand right now, you're right, is always the tech companies, but we don't have that many impressive tech companies in Malaysia. Like for example,
Mm-hmm.
Grab, AirAsia, these are, if you consider them as tech company, then they hire a lot of data scientists. Not just data scientists, they hire a lot of data analysts, data engineers. A lot of my students work there. And if you talk about other stuff like construction, say those traditional industry, then they don't. They're very conservative in a way. But legal, accounting, these are sort of like the traditional industry that starts to adopt data science. And we have other industry like medical. Yeah, we use a lot as well. E-commerce, retail, shopping malls. These are the one that uses a lot, and the one that use data heavily are like digital marketing, for example. We need to
Mm-hmm.
know what our customers are thinking, what sort of stuff they like, what sort based on their actions. TikTok, YouTube, those are very heavily data driven. Every one of us, you see YouTube as an entertainment platform. They see all of us as a data point only.
Yeah, exactly. All right, so there's a questions from Maxine. Is statistics and probabilities math knowledge important in data science? If so, how can we improve our math skill?
Okay, so definitely they're important, but it will not ruin your career if you don't know them. So our academic training on probability theory, right, is always on things like uh you have a bag of balls, and inside got red color balls and blue color balls, and then take out a blue color ball. What is the probability that you take out a blue color ball? And then if you don't put it back, what is the probability that you take out another red color balls? And see, the way that I mention it is already very boring, right? Yeah, but that's the traditional way. In data science, like I say, right, our probability theory are more observations. Like in our data set, this example that I've shown you, you have 23% of people resign, then that's it. The data shows you that 23% of the people resign. I mean, and anyone with form 1 form 2 kind of mathematics is able to understand. If you have 3 out of 10 people resign, it's 30%. As simple as that. So the probability theory that we have comes from here, and then we do more segregations, like, okay, out of this 30%, how many of them come from sales department, how many of them comes from marketing department, and so on and so forth. So this is what I call a frequencies. But the maths also that we use here, right, is not so much on the calculus or those algebraic mathematics. It's not like all those on trigonometry, but you need to know more about, like what I have been telling you, how to count things. Yeah, how to, let's say you have you go to a e-commerce store, right? Okay, you do a lot of shopping, yeah, on Shopee, Lazada, and then now your boss give you a task. Say if a person come in and then they browse a product for 3 minutes, but he or she didn't buy. What is the reason? Okay, so what is the mathematical reasons behind these 3 minutes and then the sales is zero? So you have to you have to be able to count and calculate the conversion rate. So if 100 people come in and view the product and only one person did not buy, then probably this product is not the right fit for this person. But if 100 people come in, 80 people also did not buy, that means this product is probably too expensive for most of them. Or depends on what other actions that they take. They probably don't like the recommendations, for example. Yeah, so this is another way. And go back to Grab example, right? We do the fare calculations also. Like there are 100 people waiting for Grab in a particular area, and then there are 50 drivers at the airport. So how do you incentivize the 50 drivers from the airport to drive 10 minutes to, let's say, Sepang to pick up people from the race course? Yeah, all sort of things like that. So if you ask me, like, does it involve maths? Of course, is after all, it's all numbers, right? But does it really involve theoretical mathematics? Not so much, unless you're working in machine learnings and those more abstract stuff. Yeah, I don't work on abstract stuff, as in I'm not good in imagination. So I work on more technical applied science kind of stuff.
Thank you for the sharing. So there's another question from Bonnie Lau. So she's asking for what's the main difference between data science and digital engineering?
Okay, so data science a is a technique, okay, that we use data to make decisions. So we turn it into a scientific process. So it's different from other sciences. Let's say you talk about biology, you talk about physics, you talk about chemistry, right? It's all about modeling. Biology is about modeling your human body. Chemistry is about modeling the elements that the H2O, CO2, and then physics is about modeling the uh, like the movement. In physics, we study the universal movement, from the movement of a tire on on your car, right, and then to the movement of the sun and the earth and the moon, so to speak. Okay, so in physics we study the movements, but data science itself, right, we study the science behind using data to make decisions, like those examples that I've given before. And that whole process includes like how to gather data scientifically. So today, if you want to know how many people are there going to vote for a particular party, some of you are going to vote next year, right? You are turning 18. So how do you decide which party to vote for? For people who are at your age and people who are at your parents' age, your voting patterns are totally different. So that's one way to look at things. And how TikTok decide what you want to watch, how Instagram decide what you want to see. Those are the sort of data science things that we are talking about here. Digital engineering is to digitalize the entire engineering process. So let's say you're designing cars. Last time when you are designing a car, you have to go through all the tests, like aerodynamic, I don't know, like dynamic, aeronautical, those sort of how air is going to help your cars to move more stable. And then the same theory goes to, like, when you design an aeroplane, when you design a water pump systems, all sort of thing, Archimedes principles, that sort of stuff, right? And now with all the 3D modeling skills, with all the digital tools, can we reduce the cost, or can we make it cheaper by doing all sort of simulations on the machine first, or using some digital equipment first, before you actually build a prototype, or before you actually paint the car, and we want to see how the car looks like, how the car will perform on a certain track, a certain material, certain type of roads. And that's what digital engineering is about. So it involves another theory or another field of study called digital twins. That means you have a physical object in the real world, and you build an identical twins of that object, but in the physical world. A little bit like, metaverse, that sort of things, but we don't want to go there lah. But you just keep in mind that there is the process of digitalize your engineering process, so that you can have a digital copy of what you are doing in the physical world. And from academic point of view, or from a study point of view, right, is to speed up the process and to reduce the cost. Yeah.
Cool. I think that explains the differences. So I think one last questions from Vignesh. So Vignesh is asking for a place where we can practice real life data cases to gain more experience.
I can take another questions after this, but Vignesh, go to Kaggle.com. You can get everything that you need from there. Work on real world use cases, work on real world data sets. Just go to Kaggle.com and select data sets. There are hundreds of data sets from credit cards data, data science job salaries, McDonald's menu, you know, yeah, all sort of things. Diamond prizes. I'm sure that you will be very excited. TikTok data sets, monkeypox data sets. Yeah, don't get those toy data set, but get those real data sets from here. You will improve very fast from here. Let's say if you like computer vision, right? Yeah, all the cats and dogs. See, shoe cover images, how to recognize the shoes type. Very interesting data here. Okay, go to Kaggle.com. Okay, one last question. You're welcome, Bonnie. Welcome, Maxine Vignesh. Okay. 1 minute, one more questions.
Yeah, so we'll open for 1 more minutes for the last questions. So anyone do have any doubts in this data related field, do leave your comments here. So if no, I think that will. Oh, here comes the last questions from Hui Yun. So I think she's asking, to become a
Yeah,
data scientist, it is a must. Yeah.
bachelor is enough, more than enough. Yeah, you need a lot more work experience and how to use the tools. Of course, some sort of certifications, boot camps, or those will be helpful. Yeah, to fast track your progress. But at the end of the day, just okay, this is the thing that I always say, right? You go to a business school, most of your teachers, most of your lecturers, they have not run a business before. They have not started their own business as well, right? Yeah, and unlike those technical courses lah. So I would say you don't need a master's or PhD for sure, but you, as long as you know the three key things: mathematics, statistics, programming language, and then your domain knowledge. Most important is, like I say, I have been saying, you know how to ask questions, you know the business, the domain very well. That's sufficient already. Yep.
All right. So thank you, doctor, for the answer in for the questions. I hope that helps Huyen in deciding maybe her route in becoming a data scientist. So I think that also marks for an end for our workshop today's. Is there anything you would like to add on, or would like to have a maybe a last remark for our students in the workshop, doctor?
Sure. I'm very happy to see that many of you who join me in this event, and I'm very glad to be invited again to speak at MSTW. Yeah, so I really hope that if you guys find this tutorial useful, don't just stop here. Okay, share this with your friend and send me an email, or you can connect with me on social media, LinkedIn, Twitter. I usually respond very quickly, and then yeah. So let's spread the good words and help more people to learn more about data. It's not a black box. It's not something that's mystery. Yeah, it's a skill that everybody need to know. In 15 years time, it will be like just like Excel. Everybody will know how to use that. All right, thank you very much. Have a good week ahead and take care.
All right. So thank you, Dr. Lau, again for this sharing and the workshop just now. So we have a great time today, and it's really a great sharing just now. We really appreciate doctor's advice and wish you a great day ahead. So thank you, doctor. So before we end this section, we'd like to have your favor to help us in filling in this feedback form. So it helps in ensuring us for providing a better projects. You can just scan the QR code shown at the screen and fill in the feedback form for us to improve our program. Thank you. We'll also later provide this link in the comment field so that you can fill in the feedback form through the links directly. And here is the MSTW22 giveaway form. Do fill in the giveaway forms to have a higher chance in winning our attractive prizes like JBL Go 3 speakers, Logitech signature mouse, also cash vouchers in different platforms. So do join our giveaway and we wish you good luck in winning these attractive prizes. And finally, we would like to raise a program, a fundraiser for TFM, where we MFTW have collaborate with Tech for Malaysia, that we are having a fundraising campaign to help the underprivileged children in Malaysia to continue their studies by giving sponsors in multi-way, including giving helps in devices or the needy staff in their study. So do support us, and with every 50 ringgit raise, 2 students will be positively impacted for a month. And I think that marks an end to our sessions today. And we'll have another panel discussion session this afternoon at 2 p.m. We invite 4 panelists to have discussions on these current situations on the data science situations currently in Malaysia, and also to discuss on the future developments and further chances that available in Malaysia for the data scientists. So do join these panel discussions if you are interested to know more. So that's marks end to this workshop today. Wish you all a good day and goodbye.